Okay, hello. Once again, we are back in the channel. Welcome back. So as promised, in today's lesson, we're going to be looking at functions. So here we are given a hyperbola function and an exponential function. So it says given f of x is equals to -3 over x plus 2 plus 1, which is the hyperbola function, and g of x is equals to 2 to the exponent of -x minus 4, which is the exponential function. 5.1 says determine the function of f when x is equals to -3. So basically this notation here tells us that x is -3. So wherever we see x in f of x, we have to substitute by -3. As you can see here in the position of x, we now have -3. So this, in other words, is telling you to substitute -3 wherever you see x. So to just solve that one is simple. You just go writing the equation is f of x is equals to -3 over x plus 2, and then is that 1? Yes, plus 1. Then if we have f -3, as you can see, it's even 1 mark, so we just come here where there is x, I'll put that -3. Then I have -3 plus 1. Then calculating this one, we have -3 plus 2 gives us -1. So -3 divided by -1 is +3, and then plus 1, that's just gonna give us 4, right? So yep. Then 5.2, it says determine x if g of x is equals to 4. So now we must determine the value of x when g of x is equals to 4. So this one is saying now in the place of g of x, we must substitute with 4. So now we are looking for x, and then we are substituting our g of x as 4. Then let's run quickly to it. We have g of x is equals to 2 to the exponent of -x minus 4. And then here, what do we have? We have 4, and then 2 to the exponent of x minus 4. Then if we take this 4 and transpose it to this side, we have 4 plus 4, which will give us 8, and then 2 to the exponent of -x. But then we know we can write 8 in terms of our exponents. So we know 8 is 2 to the exponent of 3, and then 2 to the exponent of -x. At this point, we can see that we have the same basis, and then reminding ourselves of our exponential laws, if we are in an equation and the bases are the same, we can just drop the exponent. So we have 3 -x like that, and then we can just divide both sides by -1. So we have x is equals to -3, right? Then in 5.3, it says write down the asymptotes of f. Write down the asymptotes of f. So f, we can see we are being referred to the hyperbola function. So we know hyperbola function has two asymptotes, which is the vertical asymptote and the horizontal asymptote. Now to find the asymptotes, we know for the vertical asymptote, we just take this part here, the denominator, and equate it to 0. So we have x plus 2 is equals to 0, and the equation of the asymptote will be x is equals to -2, and then we know the one for the horizontal is just represented by this constant here, so it's y is equals to 1. So writing our answer for 5.3, the equations of the asymptote is x is equals to -1 and y is equals to, not -2 meant to say, so let's erase here. So we have x is equals to -2 and y is equals to 1. Pardon me there. Then in 5.4, it says write down the range of g. Now to determine the range, we know that this here in our exponential graph, this value here, the value q, represents our asymptote. So we know with our exponential graph, we have something like this, right? Whereby we know this asymptote, the graph will start above the asymptote. So if they tell us what is the range, then we have to say this graph will begin at a value that is greater than -4, at a y value that is greater than -4. So the range for that 1 mark will just say y is equals to y is greater, meant to say y is greater than -4. Then 5.5, it says determine the coordinates of x and y intercept of f. So here we must calculate the x-intercept and the y-intercept. Remember, that question is always there, right? So we have our f of x. Let's write our f of x first. Then it's x plus 2 and then plus 1. Now to calculate the x-intercept, we know we have to make y 0. So where there is y, we put 0. Then we know our y is our f of x. So this is the same as saying f of x is equals to 0. So where there is f of x, I substitute 0. And then now I start calculating for my x. Then plus 1, we take this one, we transpose it to the left-hand side. And then we have -3 over x plus 2. Now when we cross multiply here, we will have -x minus 2, and then it's equals to -3. Then we can take this -2 and transpose it to the other side. We have -3, and then -3 plus 2, it's gonna give us -1. Then we can divide both sides by -1. So our x is equals to 1. Now writing this as a coordinate, we have 1 is to 0. Remember, our y is 0. Then to calculate for the y-intercept, we make x 0. So where there is x, I will put 0. So this one is the simplest because you just substitute with 0 where there is x, and then you get your answer like that. So we have -3 over 2 plus 1. So we can write this one as 2 over 2. Just doing like this because I don't have a calculator. So here it's -1 over 2. And then writing it as a coordinate, it's 0 is to -1 over 2. Then 5.6 says determine the equation of the axis of symmetry of f which has a negative gradient, Now you will remember that I said that if you are calculating for the axis of symmetry with the negative gradient, you just simply take this like this. So obviously your f of x will be, you will now put y here. And then since they're saying negative gradient, you just have to put this inside the bracket and put your negative here, then start calculating. So for your f of x with a negative gradient, now you will take this. So we have f of x or y. So we'll have y, and then that's -x plus 2 and then plus 1. So our equation will be -x minus 2 plus 1, and then the equation therefore is -x minus y minus 1. So that's the equation of the axis of symmetry with a negative gradient. So now they said leave your answer in the form of y is equals to mx plus c. We can see it is in that form where the gradient is -1 and the constant or the y-intercept is -1. Okay, so let's look at 5.7. It says sketch the graphs of f and g on the same system of axes. Clearly show all the intercept with the axis and any asymptote. So remember, for the graph of f, we already have all that. The equations of the asymptote was x is equals to -2 and also y is equals to 1. Then we had our coordinates for the intercept, which was 0 is to 1 is to 0 when we were having the x-intercept, and then also 0 is to -1 over 2 when we're having the y-intercept, right? So we have all this. This is all enough for us to draw the graph of f of x. So now, starting with our asymptotes, of course. So remember, every time you're drawing a hyperbola, you want to start with the asymptote. So remember, every time you are drawing a hyperbola graph, you want to start with the asymptotes. So there you go, with your vertical asymptote crossing on -2, and then you have your horizontal asymptote passing at +1, So like that, all the way like that. Then you want to indicate your intercept. So we have the y-intercept was 0 is to negative half. So it must pass here. It must pass here. And then the x-intercept was equal to 1. So it must pass here. And then joining this, it will give you your hyperbola graph. So we know that it will be on the second and the fourth quadrant because A is positive. Then here we just draw the other wing like that. Yeah. So second and fourth quadrant because it is positive. Then here you can just come and indicate this is 1 is to 0. And then this is 0 is to negative 1 over 2. Then your equations of the asymptote here, you have y is equals to 1. And then up there you have x is equals to negative 1 or negative 2. So let's clearly indicate it here. Make it bolder. Right. So this is your graph for f of x, right? So this is your graph for f of x. Now, what about the one for g of x? So for g of x, we want the y-intercept and the x-intercept. So to find the y-intercept, we know we make x 0. So this is y is equals to, so our g of x here becomes y, and then 2 to the exponent of 0 minus 4. This will give us y is equals to negative 3, which is now 0 is to negative 3. For the x-intercept, we make y 0. So we have 2 to the exponent of negative x minus 4 is equals to 0. Then we can take this 4 and transpose it to the right-hand side. But then remember, we can write this 4 in terms of exponents. So this is 2 to the exponent of 2, because we want the bases to be the same so that we drop the exponents. So at this point, we can divide by negative 1 both sides. And then this is negative 2. So we have negative 2 is to 0. Now we have the x and the y-intercept for the graph of g. And then remember, this one is indicating the asymptote. So our asymptote is equals to y is equals to negative 4. Y is equals to negative 4. Then drawing it here. So let's choose another color for that. We have our asymptote here at negative 4. Our asymptote at negative 4. Like that. And then now let's indicate our intercept. We have 0 is to negative 3. So that's your y-intercept, 0 is to negative 3. And then what about your x-intercept? That's negative 2 is to 0, so it's here. Then now you will just join these points. Kind of messy. So join these points like that. And then now you have your g of x like that. Now remember, this asymptotes here, the asymptote of the hyperbola, are not restricting the exponential graph. The exponential graph is only restricted by its own asymptote, which is at negative 4. So now you have your graph like that. And then, yeah, awesome. So we can just indicate here, this is 0 is to negative 3. And then here we have negative 2 is to 0. Right, then you have your asymptote here at y is equals to negative 4. Looking nice, looking nice. Then, okay, 5.8, it says if it is given that f the function of f when x is -1 and is equals to the function of g when it is -1, then determine the value of x for which g of x is greater than f of x. So basically here they're telling us that at -1, these two graphs are intersecting, they're equal, right? Remember, when they intersect, that means they're equal. So that means somewhere here we can even see it is indicated by our graph. So we can see that somewhere here they're intersecting. And then now that we've drawn our graph perfectly to scale, we can even see what they're talking about. So here we can see that the two graphs, the graph of f and the graph of g, are truly intersecting, right? So they're equal at this point. But then the question is saying, find the values, determine the values of x for which g of x is greater or equal to f of x. So what does this mean? It means we are trying to find the values where the graph of g is either above the graph of f of x or equal to the graph of f of x. Then now we can see that means we are looking for this dark line here. So what is this dark blue? So we are looking for this dark blue graph, the points where this dark blue graph is above the red graph, right? So at this point we can see, if we can follow here, we can see which graph is above the other. So the red graph is above the blue graph, so this is not the point we are looking for. Remember, g of x must be greater or equal to f of x, so it must be the graph of g that is above. Now we can see something that is happening here just after the asymptote. After the asymptote, we can see that the blue graph is above the red graph up until the point where they intersect. So what is the interval for this point? It's -2 all the way to -1. So how do we indicate that? We say x element of -2 up until -1. So but then remember, with this one we need to ask ourselves now, what bracket should we use? So because they're saying it must be greater or equal to, that means -1 is also part of the solutions. So now note here, we must then use a square bracket to indicate that -1 is also part of the values, because now they said where g of x must be greater or equal to f of x. So we can see that at point -1, the two graphs are equal. And then according to our inequality here, they said we are looking for where g of x is either greater or equal to f of x. So this is where x is an element of -2. So -2 cannot be included, because remember, the graph of there is no value for the graph of f where x is -2, because remember, that is the asymptote. So we'll say where x is an element of -2, round brackets, to -1 square bracket. Now another way to indicate this is to say x, and then you say x must be greater, so it's x must be greater than -2 like this, and then less or equal to -1. So you can indicate it this way, or you can indicate it that way. So let me erase this one. Yeah. So these are the two ways in which you can indicate that. It's either you indicate it this way if you are used to this, or you indicate it like this. So all the best, guys, with your functions, all the best with your June exams. Make sure that you practice and practice thoroughly.